For number 10, we are given a figure, and we're told that in the figure, set R is equal to 164 ohms, C being 76.3 microfarads, which is the capacitor, and L, the inductance, being 322 millihenries. Our F of D is going to be 60 hertz, and our alternating EMF is here, and that's going to be 5.87 volts. We're asked to find Z for part A. Before we start the problem, we should write down what we have. First is that R is equal to 164 ohms. Next is that C is equal to 76.3 microfarads, and L is equal to 322 millihenries. And also that our frequency F of D is equal to 60 hertz. Also note that our alternating EMF is 5.87 volts. For part A, we're asked to find Z, and we need to use this formula. And that is Z is equal to the square root of R squared plus XL, which is the inductance, minus the capacitance, X of C, all that squared. And that's how we find that. From previous problems, we know how to find our X of L and X of C, and that will be like this. If we're not given our X of L and X of C explicitly, since we're not given our X of L and X of C explicitly, we're going to have to use these. And we can start plugging in our values, and that is going to be, then we're going to start with our X of L. Our X of L is 322, and we have to multiply this by 10 to the negative 3 to make it henries, multiplied by 2 pi, and then our frequency, which is 60 hertz. After we plug all this into a calculator, we are going to get approximately 121. Next, we can solve our X of C, and for this, we're going to have 1 over our C, which is 76.3 microfarads. Converting this, it's going to be 76.3 times 10 negative 6 farads times 2 pi, and we need our frequency, which is just 60 hertz. This is all underneath 1. After we do this, we are going to get that X of C is approximately 35. Both of these are also, the units for these is ohms for each of the X's. X of L is ohms and X of C is in ohms. We have our XL and X of C values. We also have our R value, which is our resistance up here. So all we need to do now is plug these in. From here we can write Z is equal to the square root of our R squared, which is 164 ohms. All that's squared. And we're going to have a plus our X of L, which is 121 ohms, minus our 35 ohms, which is our X of C, which is all squared. After we plug this into a calculator, we are going to get approximately Z is equal to 185.2 ohms. And that is the answer for Z. Slightly inaccurate, but that's because we rounded our X of C and X of L. For part B, we're asked to find the phase shift. For our phase shift, we can look to a previous problem and note this formula. Previously we used it to find our R, but now we can use it to find our phase shift. If we put this in here like this, we can rearrange it to say that our phase shift is equal to tangent -1, so that'd be arctangent of our X of L minus our X of C over our resistance in parentheses like this. Well, in the previous problem, we found our X of L and our X of C, and we know our R, so we can just plug in these values and say that our phase shift is going to be equal to the arctangent of 121 ohms minus 35 ohms all over 164 ohms. Our ohms are going to cancel out. After we put this in our calculator, we are going to be left with the phase shift of approximately 28 degrees. For part C, we're asked to find I, which is our current, and that's going to be written in amplitude. The formula for this that we're going to have to use is just I, our current, is equal to our alternating frequency over our Z. And this is similar to I is equal to V over R. We can see that these are similar because this is something we're familiar with, and our V is our alternating EMF, and our alternating EMF is written in volts, and our Z is written in ohms, which is the same unit for resistance. If we continue this here, we can write that our alternating EMF is 5.87 volts over our Z, which is 185.2 ohms. After we put this into our calculator, we are going to get approximately 0.032, and this is going to be written in amps. And that is the answer for part C.